Let us take up the following problem. Let us try to find out whether the following signal is periodic or not. Let x of t is equal to cos 2t plus cos 3t plus cos 5t. So we want to find out whether the signal is periodic or not. It's periodic. So it is going to be here W1 is equal to 2, W2 is equal to 3 and W3 is equal to 5. So W1 into T1, that is 2 into T1 is equal to 5. So T1 is equal to 5, whereas 3 times T2 is equal to 2 pi. So T2 is equal to, for the second term, this is for the second term. And finally for the third term, is going to be 3 times T3 is equal to 2 pi. So T3 is equal to 2 pi by 5. Now the following condition will have to be satisfied. M times M2 is equal to P times T3, that is equal to the time period T. So m into pi is equal to 5 seconds is equal to n into 2 by 3 is equal to P times 2 pi by 5. This I can write it as I have to choose m, n and p appropriately. M, n and p should be chosen appropriately. These should be integers, chosen as integers, such that the equation that is mentioned, whether the equation is satisfied. So if I choose m is equal to 2, n is equal to 3 and p is equal to 5, the following condition will be satisfied. So I will end up getting 2 pi. So which is the time period t. So t is equal to 2 pi. So therefore this signal that is given at the top is periodic. Okay. So let us take the next problem. Let us try to find out whether the following signal is periodic. It is an exponential signal which is given to us, e to the power of j times 8 pi by t. This is the Euler form, and the normal polar form, or the normal form of in terms of cos and sine. We can express it as plus j times sine 8 pi t. Here omega is equal to 8 pi. So which means omega into t should be equal to 2 pi. So 8 pi t by 2 pi. So we are having t is equal to 1 by 4 seconds. So this signal is periodic. That is our conclusion. Let us take one more. Let us try to find out whether the signal is periodic. 2t cos t u of t. The signal by itself, by this signal would have been periodic. There would have been some, if we have analyzed the signal, this would have been periodic. We are not sure, okay, but we have to do some trigonometric manipulation and then try to find out the time period for the signal alone. But once you multiply the signal with u of t, the signal becomes aperiodic, because u of t signal starts only from t is equal to 0. Okay. So when you multiply a periodic signal with u of t, which is not periodic, the signal becomes aperiodic. Okay, next we take up the next one. Let us try to find out whether if the signal is periodic. Now sine 10 pi is periodic. There's no doubt about it. But the moment it is multiplied by e to the power of my exponential term, it becomes aperiodic. So the signal will be something like this. So this concludes our discussion. Okay, this I think concludes our discussion on the first of the fourth problem. Now let us take another problem. Let us take one more another problem. If we have the following integral, let us say we are having this integral delta of t cos 3t by 2 dt, then this delta this function can be written as delta of t minus 0 into cos 3t divided by 2. Now this 0 will have to be substituted into this. So if I substitute the 0 into the t of cos function, then this cos function gets evaluated to 1. So finally what we get is, when that becomes 1, so the integral reduces to this form, and we know this the value of this is 1. Okay, so this is the answer. Next, let us take another example. If a signal f of t has energy E, the energy of the signal f of 2t is equal to, so we have to find out the answer for this. So suppose if we are having a signal something like this. So let us say we are having a signal. Let us say it is say 1 1 and it is having an amplitude of 1. Now we know the energy is nothing but integral of -1 to +1 1 the whole square dt. Now if you try to find out, it is going to be, if you evaluate this integral, it is going to be joules. Now when this function, this is f of t, so f of 2t, I have to just divide the time axis, each value on the time axis by half. So my signal is going to become like this. Now the energy for this, if I evaluate, it is going to be, this is f of 2t. If you evaluate the signal, if you try to find out the energy, it is going to be 1 joules. That is, the energy is reduced by half. So the energy, if the energy of f of t is E, then energy of f of t2 is equal to E by 2. Suppose we are having a function, let us say we are having a function of this kind. So we will, let us discuss the next problem. Suppose we are having a function something like this. So this is a signum function in fact. So we are having a signum function. We want to find out what is the even part of the signal. even part of the above signal. The even part of the above signal so what we know that to find the even part of any signal, it is nothing but x of t plus x of time reversal of x then divided by 2. So I know what is x of t here. Now it is x of t, and what is x of negative of t is going to be like this. So when you add up these two and then divide by 2, you end up getting, so this is going to be half and this is going to be negative. So this is your even function. Oh, sorry. I think I made a mistake here. So it is going to be it is going to be 0. So this part and this part, when you add these two and when you add these two, this will result in 0. So the even part of the function is 0. So what about the odd part of the function? So let us see the odd part. So what is going to be the odd part? The odd part of the function is nothing but x of t minus t divided by 2. So this minus this, so it is going to be 2. This minus this, so it is going to be so first this this minus this, so negative 1 minus negative 2, which is nothing but negative 2, and here it is going to be positive 2, but I have to divide it by 2. So when I divide this by 2, I end up getting 1 here, and it is going to be minus 1 here. So this is going to be the odd part of the function. So this is your odd part. So even part is 0, and the odd part is the function itself. In fact, it is x of t itself. Okay, so let us take another example. Let us try to find out the even and odd part of u of t. So we know that u of t is this. This is u of t. We also know that negative u of negative t is this. It is 1. This is also 1 here. So when you add up these two, this plus it is half, and divide by 2. So the even part is So even part of u of t is this, and when you subtract this from this minus this, it becomes, and divided by 2, so your function becomes the function will become like this. So this is your artifact. So to check whether what we have done is correct, you just got to add up these two. When you add up these two, you should get back this function. So when you add, this is positive and this is negative, so this will get cancelled out. And this side you are having a half and you are having a half here. So it will get add up and you will end up getting u of t. So what we have done was correct. So let us take the next problem. So let us try to find out let us say we are given a function x of t is equal to delta t plus 2 minus delta t minus 2. We want to find out, let us say we want to find out a function which is nothing but the integral of x of tau d tau. So it is nothing but t, and this is delta tau plus 2 minus delta tau minus 2. Now this one is nothing but, when I have an impulse at -2, and when I integrate this, when I integrate an impulse which is present at -2, I end up getting a function like this. This is nothing but u of t plus 2 negative, and when I do the integration, I have an impulse at 2 plus 2, and when I do the integration, it becomes a signal like this, and this is nothing but u of t minus 2. When you subtract this signal from this signal, you end up getting a signal which is like this. So u of t, so this is 2 minus 2, this is plus 2. So u of t plus 2 minus u of t minus 2. So this is your y of t, which is the required answer. Next, let us try to find the period of the function cos pi by 4 to 1 minus t. This I can write it as cos pi by 4t minus pi by 4. So your omega is nothing but pi by 4. So pi by 4 times t is equal to 2 pi. So t is equal to 8 seconds. Okay. We are having a signal, let us say we have a signal x of n is equal to cos 2 pi by 3 n u of n. Now I want to find out whether the signal is definitely not periodic, because even though it can be proved that the signal is periodic, the signal is not periodic. So this signal is not periodic. Let us say, suppose, because it is being multiplied by u of n. Say, let us say we are not having this u of n. Let us try to find out the period for the signal. So the period for this, for a discrete time case, the way we find out the period is, it is omega into m, omega into n. n is the period of the signal is equal to 2 pi times and m. So n and m should be integers. N is the smallest positive integer for which this equation is satisfied. So we have 2 pi divided 3n is equal to 2 pi m, and it is into 3m. So this n will be the least if m is equal to 1, and this n should be also be an integer. When n should be an integer and it should be the smallest possible value, and m also should be an integer, in which case, so we have to put it as 3. So 3 is the time period of the signal. Okay. Okay, let us take the next case. So let us say we are having a signal something like this: 0, 1 and 2. This is x of t, and we have to find out some shifting operation that will result in so we have to do all the basic operations. Whatever basic operations is that the signal becomes like this. So this is one here. So what I can do is I can shift the signal backward. That is, I can first shift the signal like this. So when the signal is shifted backwards or advanced, it becomes something like this. So it will be -2, 0 and -1. Now if I want to get the signal, I have to scale the time by 2. When I do the scaling of the time by 2, I get this. So I have to necessarily do this. I have to do this basic operation on this signal in order to arrive at this. Okay. Okay. Let us try one last problem. Let x of n is equal to 1 minus to infinity delta n minus 1 minus k. So first let us plot the signal. How it is going to be? It is going to be something like this. So when n is equal to 1, it is going to have this is when x of n is equal to 1. Okay. So when and n is equal to, and this one, this is nothing but it starts from 4. So this is delta k is equal to 3 minus n minus 1 minus k. So when you subtract these two, you end up getting a signal something like this. So let us say we are having sequence, and it extends on both directions. Okay, and this extends only in direction. So if this extends in this direction, and finally, so this is 2, 1, and finally you have 3. So this is this one. So we want to express x of n is equal to u m n minus k. That is, this signal I want to express it in this form. How to do this? If m is equal to -1 and if k is equal to -4, or it is -3. When k is equal to -3, we end up getting this function. Okay. So these are the answers. So we stop here. In the next session, we will discuss about we'll discuss about introduction to systems. So this completes our discussion on introduction to signals. Thank you.